I welcome you all to the Spark Research YouTube channel. This is Dr. Virchandra, Assistant Professor in the Department of ECE. And in this session, we are going to take the questions which has already been asked in GATE 2024 from this course, Signal and Processing, particularly belongs to the first two units. Right? So let's take, before going ahead, let me tell you this course is very important, not only because of that, the 6 to 10 marks directly it will come. Apart from that, if you have the knowledge about this signaling system, you can easily solve the questions related to the different subjects, particularly the network theory as well. Right? So let's take the question. Question is a causal and a stable LTI system with impulse response ST produces an output YT for an input signal XT, right? So it is given impulse response st is a transfer function and yt is your output and xt is your input, right? So a signal x half of t is applied. Now this is the another input and stable LTI impulse response this. So what will be the output? Now input and transfer function is given. So what will be the output? So this is the question. So as per answer key, your answer is A is correct, right? So that is twice twice y 0.5 t, right? So how can we find out? So exactly in the convolution term, since we have to find it in the time domain. So in convolution means actually xt and h of t in convolution, and in the frequency domain it will be the product of both. It means the input and the transfer function, right? So in frequency domain, since we have to get the answer in the time domain, so we can use this and we'll get, right? So so first thing is that this is the convolution, that is the product. So here in the frequency domain you can write x of omega into h of omega, right? And then we will shift according to the time domain, that is how we are shifting, and then correspondingly we can observe the output, right? So we will get the answer. So these are the steps. Okay, let's see. So first yt is given xt into ht means convolution in terms of the y of omega, that is in frequency domain. We can write transfer function into the xt, that is input. So impulse response now for the new, that is second system, it is given h of half of t and this is our input signal. So final output will be the convolution of both h and x. So in frequency domain we can multiply. Okay, so here how are we getting it? So use the time scaling property. So in the time scaling, if we'll do then the convolution, that is in the product in the frequency domain, it will be 1 by a y of at, right? So in the frequency domain, so same things we are writing in the time domain, right? And here yt already we know that this one, right? So from the system 1, clear? So now we will put the value of a, that is equal to 0.5 in order to satisfy our condition, right? Because here h of at, right? So that is half of t. Now if we'll put, then we'll get 1 by a and half of 0.5 t. So finally it will be twice of y and 0.5 of t, right? So here is now another question. So in this question, consider two continuous time signals xt and yt. Suppose this is your xt and this is your yt as shown in figure. Now fx x of f denotes the Fourier transform of this function. Then what will be the Fourier transform of this in terms of the x of f, right? So this is the challenge. So as per answer key, any of the answer is correct, that is empty. So we'll solve it, right? Because option A and B both looks like not same, little bit different. Okay, so let's solve this. How can we solve? First of all, like this is your xt, then already we know the Fourier transform of this, that is your x of f. So we can first the shift this signal so that we can achieve this signal. So first we can the shift in the time reversal, and then we can shift in the we can, if we'll shift now, and if we'll take the the mirror image along the x-axis, we will get it, and accordingly we can the shift in the frequency as well. So how can we do? So this is our signal, having the transfer function of x of f, and we will get it the y of t by using this property. And with respect to that, we will use the time scaling property and the time shifting property and the scaling property also. Will get the final Fourier transform of the required y of t. So let's see in the details. So actually triangular pulse from the is distributed from -1 to 0 minimum values and maximum values. You can check it. So we are going the width changes, the time scaling width changes from 1 to 4, and the signal expanded by the 4, and amplitude is also going to change from -1 to 1 in order to achieve xt to y of t, right? So how can we achieve? So first we have to shift in the time domain, that is by minus 0.5, so that your center will be at 0, right? And then we can have yt, we can write minus of x t by 4, so that it will scale your on the x-axis, that is time domain, and then shift by minus half, so that it will come to the origin, and then minus of x, so that it will take the the mirror image along the y-axis. So this is the final y of t. Now we have to take the Fourier transform along with the by using the x of f. So yt, you can rewrite this. And so now, since we already got the y of t in the time domain, now just have to convert in the frequency domain. So here what are we doing? We are multiplying 1 by 4 in the time, and we are shifting in the time domain by half, right? So multiplication in the time, so that will be the, that will leads to the the division in the time. So here in the frequency domain, it will leads to the multiplication, and shifting in the time by t naught, it will lead to the multiplication by this exponential function, right? So finally your answer will be minus of 4x of 4 of f, and then exponential of minus j omega. Okay, so that's all in this session. Thank you to join. If you have any doubts, please drop a comment.